Hello, welcome to the demo. Today, in this video we are going to see how to build a centralized logging solution for an observability platform with CloudAEye SaaS. The architecture comprises of two parts: the log source that generates the log data, and the centralized logging unit that collects logs from these sources. For this demo, we are going to deploy an open-source e-commerce application called SockShop. SockShop is a sample e-commerce platform that sells socks online. It consists of various microservices that interact with each other within the same Kubernetes cluster. Let us quickly deploy the sample application to our Kubernetes cluster. The SockShop application is successfully deployed to our Kubernetes cluster. Let us take a quick look at the SockShop homepage. Now that we have successfully deployed SockShop application to our Kubernetes cluster, our next step would be to set up an ELK cluster to collect logs from the Kubernetes. To do this, we will make use of our Rust SDK built with Python. Login into the SDK with the required credentials. Select any of the available configuration type. Once the Elasticsearch cluster is ready, our next and final step is to deploy a log shipper onto the Kubernetes cluster and stream logs from Kubernetes to the Elasticsearch endpoint. A Helm chart instruction set is generated for deploying the log shipper onto Kubernetes. Copy the Helm command and run it on a separate terminal. That's it. Now your Elastic should start receiving the logs from the Kubernetes cluster. Kibana is a user interface that helps you to search and visualize the data stored in Elasticsearch. Let us log into the Kibana dashboard to see how our streaming logs look like. We can see that logs from all pods in the SockShop application are being streamed to Elastic. Kibana helps you in searching data between multiple time range formats. Each log received also comes with some additional and useful metadata like the Kubernetes metadata. Let us perform some activity on the SockShop website to generate new logs. For instance, we can browse some items and add a random item to the cart. Now go back to Kibana and you see the log data for the latest activity streaming in. Along with Kibana, you can also read or export the data with an authorized Python client. The current scripts lists the indices available on cluster and then exports the last 5 minutes and 1 hour data. The data is successfully exported to a JSON file. CloudAEye's observability platform is scalable, simple, and easy to set up in just 3 steps. One can be really productive in minutes. Thanks for watching.